Okay, guys, so I'll be trying to give you a video to represent the idea of how we can connect displacement and velocity. So just like what I mentioned in the class before, so let's say we have this car or object or whatever it is, a motorcycle or anything that is traveling constant speed. So then it's constant speed. So then let's see how they work in the displacement time graph and the velocity time graph. So for example, we have the 60 kilometer an hour in 2 hours. So then if we try to draw the graph, let's say I use the red colored. So it's 60 kilometer per hour in 2 hours. It means that it goes constantly in 2 hours, always 60. Okay, so always 60 in 2 hours. And then roughly speaking, it goes like, it's just like constantly 2 hours, and then suddenly it changes the speed. It becomes, sorry, this one should be 80 kilometer per hour in the next 1 hour. So then it suddenly changes into 80 kilometer per hour. Oh, sorry, this one is okay. And then in the next 1 hour, so then starting from here, it's 80 for the next 1 hour. So it goes like this. But then the same idea can be represented in a displacement time graph, which is 60 kilometer per hour in 2 hours. It means that we could reach 120 kilometer. So then in the first 2 hours, we could go here, roughly like this. And then in the next 1 hour, it suddenly changes. So then it becomes here. So you see there is actually a little bit different, what is it? the gradient is a little bit different. So then let me, if I change using another colored, so 3 will be here. So it's kind of like this. So the gradient changes a little bit. So then we can actually have a more or a better example, or if you like, then we can, let's say, move it into 100. Then it could be, you could see it better. So what I'm trying to say, or what I'm trying to share with you, is that how is the two connected to integration and differentiation. So if we look over the velocity time graph, which is this one, so what we could have is they are actually representing one another. For example, let's just see this part, the part that I shade. So all the way 0 until 2. So if you see this one, finding the area of this rectangle, which is 60 times 2, it gives you 120, which is, if you notice, this 120 actually is represented here, the displacement. And then the next one will be, if we, let's say I erase this, and then if we do for the other one, which is the next one, let's say I put it in this, okay, so in 1 hour 80, so then it means it's 80 kilometer, so then it goes this way, this part, right? So that's why see it's 80 kilometer here, 80 kilometer. So you see that there is actually a connection, displacement and velocity. But then how are they connected? By using integration and and differentiation. So let's see how it works. Okay, let me cut it here. Okay, so imagine, or let's just name it that the function that we have in the velocity is like fx. Well, this one is fx, but the f is a capital uppercase letter. So then finding, the integration is actually talking about an area under a curve. So then having the integration of the function fx, the small f, dx, let's say between 2 and 3. That's what we're talking about, this part then. So it means like, so the area under this curve is talking about the distance covered, or the displacement of the object from the 2 hours to the 3 hours with the speed of 80. So then where is that represented by the displacement? That is actually represented here, right? So it's the 80 kilometer. So then if you see this one, how do we know it's 80 kilometer from the displacement time graph? Or it's just 200 minus 120. So then in other words, then this part we can represent by f f3 minus f2. So I think you should notice that actually this kind of way of writing the notation f3 minus f2 is actually equal with that one. Is that if we let me move the board. So then if let's say we go back again, the integration of fx dx 2 until 3 is the same as this. Isn't it actually the same with saying that if this is a derivative, then we want to try to integrate whatever the result of the derivative, it goes back to the original function, but then f3 minus f2, which is it comes from here. So that's where the integration, they are related with the differentiation. So then if you want to know exactly what the differentiation itself, then you have to go back with the meaning of differentiation. But this is, if you see how do we do integration, is they are connected. That's then where the reason why do we call integration as reverse differentiation. For example, like whenever we have y is for example 3x squared minus 4x, and then the dy dx will be 6x minus 4. Then if we reverse the question, then let's say what we have as a dy dx, why do we do it that way? So because it's just the reverse. So then that's why the reason that we need to understand the differentiation first before we actually come up with integration. When we come up with integration, we have to understand the concept, the idea that integration is talking about the area, which I'll share with you on another video.